One really, really exciting thing that Sensors is doing is machine cycle optimization. Because in the last few years, I don't know if you've noticed, in SOLIDWORKS Simulation Professional, there's a new module for event-based motion. It takes the motion simulation capabilities of SOLIDWORKS a step further, and it allows you to kind of script out almost like a Gantt chart of what action triggers the next action to occur. And it gives you the most realistic motion possible and allows you to create and simulate your machines in a very, very quick fashion, and it allows you to optimize it as well. So I'll show you one example, and then I'll show you how you set one up. I have a pretty big machine here loading up here on the screen. Looks like most of you can see it now. And I will, let me just turn on motion and simulation. So you need Simulation Professional for the event-based motion to work. And I have a motion simulation already run here. And you'll notice that it pops up like this. I'll go ahead and hit play just to show you what the machine does. You can see, I'll let that play a few times so you can watch the whole screen. You have lots of different things happening at the same time. One thing depends upon another thing. And how do you figure out exactly what timing is needed to make all this work? And this is why they pay the machine designers the big bucks, right, to figure these things out. So SOLIDWORKS with event-based simulation can help machine designers figure this out, optimize machine cycle time so they can make parts faster. So the way this is set up, let me play it again. You'll see that they're indexing the station, then we're raising the entry RAM, then it's extending the entry RAM, then it's lowering the ramp. And I'm saying that because that's what SOLIDWORKS is telling me what is happening here in this chart at the bottom of the screen. So this one, is a pretty complicated machine, a lot of stuff happening. How do you set something like this up? All right, let's go to a more simple example. So let's say we want to get this block out of this maze. I want to push this block out in the space here. I have a system of, let's call them linear actuators, and we're going to push one. Well, I'll show you completed, then I'll start it fresh again. So we're pushing it on out, one thing based on another. So how do you do this? So let's go ahead and create a new motion study. Now you notice when you get the new motion study set up, it by default gives you the traditional keyframe based animation. And you have three choices: animation, basic motion, which does some physics, motion analysis, which is the full kinematic SOLIDWORKS motion package. And if you have SOLIDWORKS Simulation Professional or above, you get one additional button here at the very end for event-based motion view, which you can toggle between. Okay? So I'll toggle here to leave it on. The next thing I will need to do is go ahead and define motors. So I'll hit a motor, and you can do this in basic SOLIDWORKS all the way up, but there are different types of motors that you get as you increase the level of SOLIDWORKS you get. So here I want to define the motor location, and the motor location I'm going to put on the very front of the plunger. So I'll just select the front face of the plunger. You see it gives you a nice arrow showing you the direction of that plunger. And motion I can prescribe here as a constant speed or a distance, like I know I'm going to move that thing 200 millimeters over a certain amount of time. But I don't know what amount of time and when it's going to start and stop. As you can see, here's the distance, the start time, and the stop time. I don't know when it's going to start. One action depends upon another. So I'm going to use the servo motor, and I'm going to say it's going to be a displacement servo motor, and this is only available in the event-based motion. I'll say OK. And it puts that linear motor in here. I'm going to call that motor 1, just so I don't lose track of things. Now I would do the same thing here for motor 2. So I'll add another motor, linear motor. The direction is going to be on the front of that plunger, and it's going to be a servo motor. And let's see, I think I screwed up the edge direction here. You can change the direction. Oh, let's say that's motor 2. So I'll start with 2 here. So under the task list here, I'm going to say, we also need a sensor, and there's already a sensor built into this block here. So it's a proximity sensor we're using in this case, and a proximity sensor gives us a virtual laser beam in which we can control the distance of the beam itself. I don't know how SOLIDWORKS figured this out, but they did. So you see it's giving you where the laser beam begins in red here, and it's showing you the distance of that beam. And we're telling it to start on that edge, reference the space for its direction. That's the component that it's tracking, the actual block itself. And here's the beam distance, 49 millimeters. And they can have it alert me, the sensor alert. So the first thing I'm going to do is I'm going to add a task, and I'm going to say the first thing I want it to do is take this motor, motor 1, and have it change its value to 200 millimeters over 2 seconds. The profile I can list from all the different types of motion profiles in the system. Maybe a cubic function, harmonic motion, sinusoidal motion. So I'll pick a sinusoidal motion. And that's all I have to do is just say 200 millimeters, a 0-second time delay. So you can see my Gantt chart being built right here on the left or the right. Task 2 is going to be triggered based on the sensor, or maybe after task 1 is complete. Initiate motor 2. Tell it to change its value to 200 millimeters. Maybe you want that to run for 3 seconds with a different type, maybe a harmonic motion. We also need to define contacts, on all the components. So that's what this contact button here is for. So I'll do a solid body contact using contact groups. And I'm going to say the block is going to come in contact with, all these plates and the plungers and the track. We can even define the material of each item, because it's going to consider the impact of restitution, the friction, restitution coefficient, and it's all going to be considered. So I hit calculate. You can see it's pushing it forward there. Oh, I pushed it a little too hard. I might not have defined my contact there as well. 200 millimeters might actually be too much as well. It actually is, because it's really 140 millimeters from here to here. So I'll just say, make that 140 millimeters. Recalculate the thing. You see how it just pushes it forward, and then it pushes the next thing forward. Let's try to reduce the actual time here. I'll just do a calculate right here. So that's machine cycle optimization right there. So really it helps you get the most realistic motion. You get to control it based on the outcome of a previous action, and you can use these virtual sensors, these proximity sensors now, to get it to move exactly when you want it.